Okay, so this first example problem is really very straightforward, and really the point of it is just to get you familiar with using the net present value function in Excel properly when you're talking about a net present value, because the NPV function in Excel really just gives you the present value of a series of unequal cash flows. To truly get the actual technical net present value, you need to take the NPV function, or the present value of all these uneven cash flows, and then add back in your initial investment. So the first thing you need to do when you're setting up these problems is to make this a negative, because it is an investment, right? And so now all we have to do, let's see, so we are looking at doing net present value at various different discount rates, so we may as well just set it up so that we can do them all at the same time. So let's see, we'll say rate is 12% and 15% and 21%. And then our NPV calculation using Excel would be, the first thing you have to do is pick up that initial investment, right? And then you add in the present value of the remainder of the cash flows. And so what you're doing is you're taking these positive cash flows and bringing them back to today's value, and then subtracting out the initial investment to determine whether it actually makes sense to do this. So what we need to do is take the present value of all of these positive cash flows up here, discounted at these various different discount rates, and then subtract out the initial investment, which we are assuming occurs now, right? So let's go ahead and set that up. So we go our initial investment, which is a negative number, and then add that to the net present value, or the present value, discounted at this rate of these future cash flows. And we will see if that looks reasonable. Yeah, that looks pretty good. Okay, so now what we can do is just go ahead and make the rows absolute values, and allow the discount rates to move, and we'll get all our answers here. So at 12% discounting, it's 5609. At 15%, right, because we value future cash flows less, and this is heavily weighted out in the future, right? We lose value because the value of this 150 and this 150 even more so goes down. So at a higher discount rate, that means we discount the future more, then our cash flow becomes negative. So at a discount rate of 12%, we can go ahead and accept the project. And at a discount rate of 15, we should reject it. And at a discount rate of 21, of course, we are also going to reject it. So remember, the whole point of net present value is that if an investment has a net present value greater than 0, then that means that the investment makes sense. Less than 0, it doesn't. Okay, the next one is one of those, these practice problems become more and more complicated as far as what information is given in the paragraph, right? So right now we are given the initial investment of $2,500. So let's go ahead and put that up top. I'm sorry, not 2,500, 2.5 million. Okay. So we can slide that across, and now all we need to do again is just use that same net present value formulation where we take our initial investment given above and then add that, because it's a negative number already, the net present value of, and we'll pick this rate here, Then we'll pick all these values. And that gives us a net present value of negative 39,000. And we can just copy that across, 456 and 578. So we like project O better because it has the highest net present value, even though it has a very high discount rate. And that is because the cash flows are front loaded. So you get your money back quicker. Okay, so let's take project O, check the answer, and it's right. Okay, so these first few are really pretty straightforward. Okay, let's look at the next one. Okay, this next one, it begins with a very, very simple additional net present value calculation. So we have a couple of different options for our investment. They are mutually exclusive, so we can either invest in the restaurant or the sports facility. The sports facility has a higher initial investment and a higher discount rate, meaning more risk. So let's go ahead and figure out the net present value of these two projects. So our net present value for the restaurant is going to be the initial investment plus the net present value NPV of that. So there's that, and again, because of the way I've got this set up, you can just go ahead and copy that formula here, but you don't want to go all the way out to column H here, you only want to go to column F, so we can just make that little adjustment there, and there it is. Okay, so our net present value of the restaurant is going to be $461,890. And the net present value for the sports facility is $197,938. And so there's that. Okay, so given that, we should choose the investment with the highest net present value, so we should choose the restaurant. Straightforward. Okay, now the next part says adjust the net present value for unequal lives with the equivalent annual annuity. Okay, so what I'm going to do is I'm going to pause this. I'm going to write the annuity formula over in the Excel spreadsheet, and then I'll talk you through it. Okay. Okay, so to adjust the net present value of unequal timelines, one of the things that you can do is create what's called an equivalent annuity, or an EAA, which is defined as the net present value over the present value interest factor for an annuity. Okay, and so that's nice, but what's the PVIFA, right? And we go through this in the videos, but I'm doing the example problems first in my workflow. So the PVIFA is equal to 1 minus 1 over 1 plus r to the n. By the way, 1 over 1 plus r to the n sort of trips off the tongue. If we were doing these by hand, you would have that in your head as well. So it's 1 minus 1 over 1 plus r to the n divided by r, or the interest rate, right? And so whenever you have a complicated formula that you need to solve out using Excel, I always recommend to break it into pieces. So let's just look first at this denominator here, 1 over 1 plus r to the n. All right, so we're just going to calculate that out. And for our restaurant example, then, if we put that formula into the cell, here it is, 1 over 1 plus 10.5 to the n is 6, right? Because this is a 6-year cash flow. Okay, so that gives us a sub-calculation there of 0.54932, and so then we can just go ahead and calculate the present value interest factor as 4.2, which is 1 minus this thing, 1 over 1 plus r to the n, divided by the interest rate. Okay, so that's the first thing. So we figure out our present value interest factor, and then we can find the equivalent annual annuity for the restaurant as the net present value divided by that number, which is 107,611.98. So let's go ahead and put that in, and there it is. And then we can do the same for the sports facility. So I'm going to pause this, set up the sports facility calculations, and then get back to you. So if we apply that same procedure to the sports facility, we get a 1 over 1 plus r to the n of 0.63552, right? 1 over 1 plus r, and it's 4 years, right? And that gives us a present value interest factor for the annuity of 3.03. Again, we take as 1 minus this number here divided by the rate, and then that gives us, for the sports facility, an equivalent annual annuity of $65,167.95, which means that the restaurant remains the more attractive option. But let's go ahead and solve this all out. So 65,167. So that one's right, and then we still like the restaurant. There it is. Okay, I'll stop the video here and move on to the next few examples.